Hello guys and welcome to a new video in physics. In this video, we will talk about lesson 4. The name of the lesson is How fast? The focus question for this lesson is how do you describe how fast something is moving? And to answer this question, we will learn it in this lesson. The new vocabulary that we will have in this lesson is average velocity, average speed, and instantaneous velocity. Here we have a definition for absolute value. Absolute value is a number that's equal in value to a given real number but is not negative. This is a definition for absolute value. What does that mean? For example, here we have, let's say we have minus 20. The absolute value of minus 20, that's equal to 20. The absolute value for minus 6, that's equal to 6. The absolute value for minus 5, that's equal to 5. And the last example, for example, let's say we have minus 100. The absolute value of minus 100 is 100. So the absolute value, it should be positive, not negative. Here we have velocity and speed, and we will learn what's the difference between velocity and speed. Consider the position time graph of two joggers. The slope of a position time graph for an object is the object's average velocity, which is represented by the equation v equal to delta x over delta t, which is equal to x final minus x initial over t final minus t initial. For example, here we have a position time graph for red jogger and blue jogger. In the beginning, we will learn how to calculate the velocity for the red jogger. In the beginning, we should take 2 points, any 2 points that you want. So, for example, I will take this point, for example, here, this point, with this point here. So in the beginning, we should write our equation, which is x final minus x initial over t final minus t initial. Here, x final for this point is equal to 6. So because the movement started from here until here. So here the position is equal to 6. So we should write 6 meter minus the second position that I chose, which is equal to 2, over the time here that's equal to 3 minus the time here equal to 1. So the final result for this equation that's equal to 2 meter per second, and this is the velocity for the right one. And now to calculate the velocity for blue jogger, we will do the same. So in the beginning, we should write our equation, which is x final minus x initial over t final minus t initial. And I will choose any 2 points. In the beginning, I will choose my points, which is here the first one and here the second one. So the movement started from here until here. So here we have the x final and time final, and here we have x initial and t initial. So x final that equal to 3 meter minus the second one we have it, which is equal to 2 meter, over t we have it 3 minus 2. So the final result for this equation that's equal to 1 meter per second, and this is the velocity for the blue jogger. The sign of the slope tells you what direction the object is moving. So for example, we have this position time graph, and we will calculate the velocity for this position time graph. So we will choose 2 points, any 2 points. For example, I will choose this one with this one. This is the first one and the first point, and this is the second point. So the movement started from here until here. So in the beginning, we should write our equation, which is V equal to x final minus x initial over t final minus t initial. After that, we will write our numbers. So x final equal to 10 minus x initial equal to 15 over t final we have it, which is equal to 2 minus t initial, here we have it, which is equal to 1. So v, the velocity, equal to minus 5 over 1, and the final result should be minus 5 meter per second. Here we have the velocity that equal to minus 5 meter per second. The minus here represent the direction of the object moving. So the movement, it should be uh, to the minus direction or to the negative direction, which is minus 5 meter per second. This when we need to find the velocity. But when we need to find the velocity, we will do the same and the same law, but we will take the absolute value for the result. So when we need to calculate the speed, also the final result will be minus 5, and because we should take the absolute value for minus 5, so that will equal to 5 meter per second. Here we have the slope's absolute value is the object's average speed, which is the distance traveled divided by the time taken to travel that distance. This is the definition for average speed. And we knew now how to calculate the average speed exactly the same way for the velocity, but we will take just the absolute value for the result. The speed and direction of an object at a particular instant is called the instantaneous velocity. Instantaneous velocity, for example, if we need to calculate the velocity in particular moment, we will use the instantaneous velocity, and this is the definition for instantaneous velocity. Equation of motion. A straight line on a a straight line on a position time graph can be represented with the equation, which is x equal to v t plus x initial. With this equation, we will find the position instead of using the position time graph. We can find the position or velocity or the time or x initial with this equation. So for example, here we have a car is initially 6 meters east of the origin. It drives west at a speed of 12 meters per second. What is its position after 1.2 seconds? In the beginning, I wrote here a sketch for the situation. In the question, I have a car initially 6 meters east of origin. So let's suppose here we have the origin. So 6 meters, it's approximately here we have 6 meters east. So the car starts the movement from this position to this direction. Now, in the beginning, we will write the noun and the unknown from the question. The noun here we have it, a car initially 6 meter east of the origin. So here we have x initial. We can write here x initial equal to 6 meter east. It drives west at a speed of 12 meter per second. So the velocity v equal to 12 meter east 12 meter per second west. What is its position after 1.2 second? So what's the position after 1.2? I need to calculate the position, which is x final, and also I have the time, which is t equal to 1.2 second. So in the beginning, I should write our equation, which is x equal to vt plus x initial. The velocity here, because the car is moving 12 to west, 12 meter per second to west. Because the movement is to west, I should write the speed equal to minus 12 meter per second. The time I have it in the question, which is equal to 1.2 second, and also x initial I have it in the question, which is equal to 6 meter. Minus 12 multiplied by 1.2 plus 6 meter, the final result should be minus 8.4 meter. We can write our result like this, which is minus 8.4 meter, or we can say 8.4 meter to the west. So if you mention the direction, so that's mean the movement is in minus, because here we have the direction in west. This is the result for this problem, and with this problem we reach to the end of the lesson, and here we have some questions about this lesson. How do you find the average speed of an object from a position time graph? Here we have 4 answers. You should write or you should choose the correct one. Number 2, what's the speed and direction of an object at a particular instant of time? Which one is the correct answer? Question number 3, which is the total distance traveled divided by the time taken to travel that distance? Here we have a definition. So this is the definition of what of these statements. Question number 4. Heather and Juanita are traveling east. What is Heather's average speed? From this position time graph, I need from you to calculate Heather average speed. The last question in this lesson is, in a mathematical representation of a straight line on a position time graph, what quantity is represented by y-intercept? Which one is the correct one? Until here, we reach to the end of our lesson for today, and we have also another lesson for or another lecture for lesson 4. We will solve the problem or the mathematic questions in your book. So until here, we reach to the end of our video. See you soon in another one, inshallah.